Storage is a fundamental need of any application. Even if you're talking about your own laptops, you need a storage to keep your photos, video, document, or any other thing you have created. Similarly, servers also need storage. And when we talk about storage, you may have to divide it into local storage and in remote storage. Now, you may not be playing with these things on a day-to-day basis, but understanding concept will help you in getting through the storage services available in other cloud providers. So let's go ahead and talk about it. So storage architecture, when we talk about a local storage, means this is my laptop, and within that laptop I have a disk, or this is my server, and within that server I have a disk. We most of the time call it HDD, hard disk drive. So these are considered as local storage, which is local to that server where it is connected, which is fast, low cost compared to other storage cost we have, and then typically used for installing operating system and non-critical data. Why I'm saying non-critical? Because this is one single disk, and if it fails, then it is your data is also gone, and that's why you may not want to keep your most critical data on it, like you do backup and all. So that kind of things can happen. So what happened initially that when the servers were created, each of these servers had their own storage disk. That is okay, but the challenge is now what I need to know that, hey, I have to connect to these servers to get access to the data. What I mean by that is this. So here are my clients, which is again desktop or machines which are trying to access something on the server. Server would have their local disk, obviously multiple, and then you would configure RAID on that. RAID stands for redundant array of inexpensive disk, in which you combine multiple disks together to create a logical unit so that you can create a failure tolerance architecture. Like you may create a mirroring RAID. In that you would say I would write A here, and automatically it will be here also. Writing B here on a disk, it is on the disk 2 also. So even if disk 1 fails, I may have my disk 2 from which I could recover, and that is referred as mirroring. So similarly, there are different RAID labels, but this is within the context of the server individually. So here storage is all connected storage to a single server. Other servers cannot directly access the data. So let's say this server here need to access this data. The request has to go from this server. If this server is down for whatever reason, then you cannot access this data here, right? And generally you would be connecting this local disk by SCSI cable. SCSI stands for Small Computer System Interface. It is just an interface or a connectivity option by which you connect your cables and then devices. And on top of it, capacity is limited in the sense there is a physical limitation of how many disks can be put inside a physical server. So that is always giving us a limit of how much physical storage we can achieve from a server. So that change, this local storage architecture was okay, but it was not designed for enterprise grade scenarios, and that's where came an option for something called centralized storage. So rather than every server having this own disk and storage, we can go ahead and create a big server, consider like that. In that we would have lot and lot of disk capacity. It is a server or a whole rack designed purely for hardware, purely for housing your storage devices like hard disk. And then how my servers are going to communicate to it. So we have to create a storage network on which request will go from this server and the response will be given, and through that all the data is stored and accessed if the need be. So we created a centralized storage architecture there, and that centralized storage architecture is what we refer as SAN, storage area network. Now, like there are different governing bodies for your component and then services. Similarly, SNIA is a well-known name. This is something called Software Storage Network Institute or something. They define SAN as a network whose primary purpose is to transfer data between computer system and storage element. So you, if you are a client, you do not directly talk to a SAN system. You talk to your server. Let's say this is a web server, and that web server has hosted the video somewhere on this. Maybe this is an accounting server and the database is hosted somewhere onto SAN. So that is how it would be accessed by the server, because it requires special hardware to access this SAN network. What happens behind the scene, that you would be creating a network behind your network. So this is your front network where your clients are connecting. That server would have additional network network interfaces by which it would be connecting to a storage cloud. This cloud is not AWS or Google or Azure cloud, but it is a network name which is given up. So in this, now we have high-end disk arrays, which are specific devices, maybe the whole rack or a portion of rack in which lots of disk component are stored. Those are called my high-end disk arrays. So that server access the network devices, these storage devices over the network, and that's why SAN, storage area network, is a network on which only the storage traffic is flowing. So your databases are hosted, your photos are stored, your documents are stored. That is happening into a storage area network. It is also sometimes referred as network behind the server. Why? See, this is a front-end network, this is a back-end network. So it is a back-end function. Client computers are not connected to the SAN but communicate with the server. I talk to server and server would go and get my data and deliver it back to me. A SAN make it appear as though the disk array that is remotely located is locally attached to the server. This network is so fast and configured in such a manner that it feels like to this server that, hey, I am just accessing something locally, but technically it will be far behind, far away, and from there my data is being fetched into. So that is called storage area network or SAN. So SAN is the network behind my server on which only storage traffic is flowing. And then to connect to these storage arrays, so these are called my storage arrays or storage devices. So these storage arrays can be coming from different manufacturers like NetApp, then you may have from HP, maybe from EMC, maybe from Dell and other companies. So all these storage arrays would be there. And to connect to these storage arrays, because what can happen, you may have front end, maybe multiple servers, back end, multiple storage arrays. So how we create a network between them? For that, we may create networking devices like this. On these networking devices would allow me to communicate to the backend, and they would be mostly having redundant network connected. So that is a SAN network. A SAN allows any-to-any communication across the network using interconnecting devices. This is my interconnecting device, as you could see here. Special protocols are used to allow my server, because this is a communication and communication has to follow a protocol or a language. So that protocol which we are using would allow my server to perform block level read write operation on the storage devices. Performance would be as similar as data being accessed from direct attach, and access to data through logical block and not to file. Mostly we mount the whole volume, and through that we can then create file, but not directly files are given access over SAN most of the time. What SAN is made up of? So there is something called HBA, host bus adapter, a physical card which allows my servers to talk to a SAN switch, which is a network component. Then within my storage array, there would be a processing unit like brain of the storage array, and then there would be storage units on drive enclosure in which my hard disk will be housed. So when I talked about that, say we would be doing RAID and all, that will be done by this. Maybe backup will be performed by this. Maybe the encryption will be performed by my storage processor, and the actual ones and zeros would be stored into this drive enclosure. So this is how a common SAN network looks like. And within this SAN network, then there are different type of protocol which are used. You don't need to know it, just to get an understanding is good enough. You don't have to remember everything. Now, as you could see here, servers would be talking to the storage processor, and then storage processor in turn will be talking to drive enclosure. So that's why we refer them as front-end connectivity protocol and back-end connectivity protocol. So front-end could be fiber channel protocol, FC as we call it, iSCSI, FC over Ethernet, and then back-end can be, depending on vendor to vendor, could be SCSI, could be SATA, fiber channel, SAS, and fiber ATA. It all depends. So this is how storage is physically presented to my server. That's how my server would have access to a device on which it can store data. But before it can start storing data, there has to be some logical operation performed, and most of the time when you talk to someone who works in data center into an old-fashioned way, they would be referring to something called a LUN, or a logical unit number. What is a LUN? A LUN is a logical representation of storage space which is given to a server. So storage device have a lot of hard disk in the backend, but you cannot directly access one single device. So what we do, let's say these are my 4 storage hard disk. We can combine them together into a logical unit, and then maybe this was 10 GB, 10 GB, 10 GB and 10 GB. So I have total 40 GB capacity, but then I said no, I would perform mirroring. So mirroring in the sense I would create a mirror in a way that I would be consuming these two devices as in one unit and these two devices as one unit. So I am now getting 20 GB of available space because 20 GB is just a mirror. So my server accesses this logical unit rather than these individual disks, and that is referred as LUN, logical unit number. So storage capacity is sliced into usable chunk, and that is called LUN. One presented to the server, it looks like a local disk. So once my server has been connected with this, server will think, oh, there is a local disk on which I can perform all the operating system tasks like installing something and configuring something or formatting. So that can be done by a server. So that is called LUN. Each LUN has an identification ID which is called LUN ID, which allows it to uniquely identify. So it is just a number by which we connect to that particular device, logical device. LUNs are accessed via SAN protocol like iSCSI, FC or FCOE. Now, how the backend operation work? Let me give you an example of it so you understand when you are using EBS volume and all type of stuff, how it may logically happen. So let's say, just taking an example, that we have a physical device here which has capacity of 12 terabyte. I'm assuming that storage controller is already present and it can perform all the operation. So this 12 terabyte, why it is 12? Because I have 12 disks of 1 terabyte each. I may not be able to directly use this 12 terabyte. What I have to do first, out of this 12 terabyte, we would first create a RAID group. So I can create different type of RAID group. Let's say I created one RAID group here, RAID group 1, and I said I would be using 2 disks for it and I would be using mirroring, which means I physically consumed 2 disks in that and 2 TB capacity, but as I am doing mirroring, I would get a usable size of 1 terabyte only. So this is first thing I create is a RAID group. Once a RAID group is ready, I would be then creating here something called a LUN. Like here is a LUN of 500 GB, another of 50 GB, another of 400 GB that I could do. Similarly, now this can be useful for one application where I need to have data redundancy, so mirroring is good. Maybe my another application require better performance. So in that case, I would say no, I don't want mirroring, but I want to have stripe set. In this case, my data is distributed across to disk in a one-to-one basis, not like a mirror basis, right? So here, what I have 2 disks associated. I would get 2 terabyte of capacity, and maybe in that I created a LUN of 120 GB and 10 GB. I have still so much capacity left, which I can use for further LUN expansion or LUN creation. Then I may have RAID groups here. RAID group 3, physical disk 4. I have used here RAID type 5, which is called stripe set with parity. In that case, I get 3 terabyte as usable space, and within that, I just created more LUNs. Now, once these LUNs are ready, my server need to access it, and that method is called presenting the LUN to the server. So I'm ensuring first that physical connectivity has been sorted, cabling and all, and now through commands or through operating system, I would be able to then present this LUN of 500 GB to my server. Let's say this is my SQL server here. It has its operating system on a local disk, but now it has been presented with one more disk, and it can say now I would partition and format the LUN. So this server can say, okay, let me use it as a D drive, and I would store my databases on top of it. So Exchange database is now stored here. SQL database is stored on that. So physically it resides on this device here at the top, but logically it is seen as a local disk to this server. Second server here, I have this Exchange server. Maybe I take this particular LUN of 400 GB and mount it. So whatever I would store here would be protected by the mirror option which I have selected. Maybe one server need another storage for fast processing and no redundancy required there. I could go ahead and say, okay, let me present a LUN from a RAID group which has my stripe set option, and now my logs are stored on that. So as you could see, one server can have multiple LUNs mounted to it, should not be a problem, and they can have different characteristics. Maybe I have another LUN. Now, in this case, I can directly boot my server from the LUN. So boot from SAN is supported. Like here, I do not have a local disk on this server, but it can directly boot its operating system from a LUN which is coming from a storage array. So that is very common. And then maybe I need to have a shared storage. So I can have this LUN, let's say 1 terabyte, and mount it to 2 server. Both of them can see that storage space and then access files with each other. So that is what is possible through shared LUN. And then I may have a LUN presented to, let's say, this Oracle Oracle database, and this Oracle server can say, okay, I want to divide this into two more logical unit of C drive and D drive, and that can also be done, should not be a problem. So we have a way of presenting storage to my server. And if you then count the total 12 disks, we have used maybe 8 of them. Now we still have 4 disks available unused. So these can be used to expand your RAID group and then expand the capacity of the LUN if the need be. So that is how you are able to provide storage to your server. Obviously, you do not do these things anymore into the cloud space, but understanding this concept that you have a physical backend that is presented into a logical grouping and then it has been carved out and sliced into smaller pieces, that's what is being presented to you. Same way, when if I relate it to AWS cloud, if you use a EBS volume, obviously, it is not implemented in the same fashion I have said, but EBS volume is similar concept. So this is your EC2 machine. This EC2 machine is running on some physical server somewhere. This physical server would be then connected over a network to a big storage array, and in that storage array there would be different type of volumes available. Let's say this is a volume of 20 GB, and now I could configure this 20 GB volume to be associated to my physical server, and then it will be mapped to my EC2 machine. So we do not see anything behind the scene which happens. We go ahead and say I want to create a volume of, let's say, 30 GB. It would be created into storage, and then we mount it to my EC2 machine. But behind the scene, this is how a logical representation of the whole operation may be happening. So I hope this is clear and you got a better understanding of storage associated in data centers. All right. So join me into next section. We'll talk about network related devices into next section. Thank you.